researchers have found a way to turn your breakfast food into a new material that can cheaply remove salt and microplastics from seawater. The researchers used egg whites to create an aerogel, a lightweight and porous material that can be used in many types of applications, including water filtration, energy storage, and sound and thermal insulation. Scientists have worked to create new materials, including aerogels for engineering applications. Eggs may be part of a staple breakfast recipe, but they could also prove an unlikely ally in the battle against plastic pollution in our oceans. According to scientists, egg whites can be transformed into a material capable of filtering microplastics and salt out of seawater. Currently, there are more than 50 trillion pieces of plastic and microplastics in our oceans, according to UNESCO's Ocean Literacy, and experts predict these amounts will have quadrupled by 2050. To curb this rising global crisis, researchers have come up with lots of ways to filter microplastics from water. The most recent invention is taking the battle against plastic pollution in our oceans to the next level. In a new study, researchers transformed egg whites into a water filtration substance that can remove 99% of microplastics from seawater. To transform the egg whites into an effective water filtration system, researchers freeze-dried egg whites and then heated them up to 900 degrees Celsius in an oxygen-free environment. After heating, the egg proteins produced a mix of carbon fiber strands and graphene sheets that can remove microplastics and salt from water with 98% efficacy. Using egg whites to remove microplastics from water has significant sustainable benefits to the environment. It is inexpensive to produce, energy efficient to use, and highly effective. Also, compared with reverse osmosis, which requires significant energy and water for operation, this filtration process requires only gravity to remove microplastics and wastes no water. Through a combination of experiments and numerical modeling, a transformation of standard egg white proteins into an ultra-lightweight GCF aerogel with a multi-scale structure was made possible. The resulting covalently bonded hierarchical structure, derived from the complex underlying protein configuration, exhibits a density that is 2 orders of magnitude lower than existing state-of-the-art materials. This method, compared with activated carbon, gave even better results. The research team is now planning to refine its material fabrication process so they can use it for large-scale water purification. They are also looking into producing synthetic proteins with similar filtration qualities, instead of using store-bought eggs.